Hello, this is Dr. Ajay Thakur, Associate Professor in Chemistry, Shahid Captain Vikram Batra, Government College, Palampur. So friends, today I am going to give you a lecture on electrophilic substitution reaction and orientation in arenes, that is aromatic compounds. Now what is electrophilic substitution reaction? Electrophilic substitution reaction is a type of reaction in which an electrophile is substituted by the another electrophile. We must know what is electrophile and what is nucleophile. Now, electrophile is a type of attacking reagent which is either cation or electron deficient, neutral but electron deficient species. Electro means electron, philic means in love with, in affinity for the electrons. So, any cation or any electron deficient, neutral but electron deficient atom or group of atom which has affinity for electrons, it is called electrophile. So, in benzene or derivative of benzene, we can see the following types of electrophilic substitution reaction. Benzene undergo or derivative undergo these following types of electrophilic substitution reaction. First is halogenation, second is nitration, third is sulfonation. Then there are two Friedel-Crafts reactions, Friedel-Crafts alkylation, Friedel-Crafts acylation, and mercuration. Now, what is the general mechanism for the electrophilic substitution reaction? Whether it is halogenation, whether it is sulfonation, whether it is Friedel-Crafts reaction, whether it is mercuration. Now, all electrophilic substitution reactions of benzene or its derivative takes place in two steps. So you can see in the slide that in step 1 there is attack of electrophile. So electrophile attacks the benzene ring, and as a result of which there is formation of a cation which is called arenium ion, and as soon as this arenium ion is formed, it is stabilized by the resonance. So there are three resonating structures. You can see that this arenium ion it is stabilized by three resonating structure, and this is the slowest step, and this is the rate determining step. And in step 2, the benzene ring, then this arenium ion, it loses a proton, and there is that is proton, it is substituted by the electrophile, leading to the formation of the substituted product. And this second step, it is a fast step. Now, the validity of this mechanism or can be justified, can be proved if we use the isotopic labeling. So with the help of isotopic labeling, if in case of instead of benzene, if we take deuterobenzene and then compare the rate of the reaction of both benzene and deuterobenzene, so we'll see that in both the cases, rate of electrophilic substitution, rate of चाहे वो nitration हो, चाहे वो halogenation है, चाहे वो sulfonation है, rate of the reaction remains the same. It means that is removal of this proton, because in this second step there is removal of proton, and in deuterobenzene it is deuterium. Because whether it is removal of proton, whether it is deuterium, it is a fast step. It does not affect the rate of the reaction. That is why both deuterobenzene as well as benzene, they show same rate of the reaction for electrophilic substitution reaction. This proves that step 1 is the rate determining step and step 2 is the fast step, and it has no effect on the mechanism of the reaction. Right? So this is the mechanism. Now what is orientation? Now, orientation is that is effect of ring substituents. When there is presence of some groups already on the benzene ring, then what is the orientation is? What is the position which is occupied by the second substituent? In which position? Because with respect to already present substituent, there are three positions. 1-2 position is ortho, 1-3 position is meta, and 1-4 position is para. So whether the second substituent, it occupies ortho position, meta position, or para position, it depends upon the substituents which are already present on the benzene ring or that is aromatic ring. So any group already on the aromatic ring affects the reactivity. So what is the effect? If there is activating group means any electron releasing group which shows plus I effect, inductive effect, or which release electrons over the benzene ring as a result of resonance effect or mesomeric effect. So when there is increase of electron density on the benzene ring, then because of increase in the electron density of the benzene ring, electrophile easily attacks on the benzene ring and rate of the substitution gets increased. Rate of the reaction becomes fast. So we say such groups which increase the electron density on the benzene ring, they are called activating group, whereas the groups which decrease the electron density on the benzene ring, such as halogens, which are electron withdrawing, they show minus I effect. So any group, any atom which show minus I effect, it decrease the electron density on the benzene ring, or there is minus mesomeric effect. So plus mesomeric effect release the electron density on the increase the electron density on the benzene ring, whereas groups which show minus M effect decrease the electron density on the benzene ring. So electron releasing group, they activate the benzene ring towards the electrophilic substitution reaction, whereas electron withdrawing groups, they decrease the electron density on the benzene ring, aromatic ring, and hence they deactivate the benzene ring towards the electrophilic substitution reaction. Now we, now we have to see what is the orientation. So any electron releasing group, all activating groups, they are ortho and para directory. An exception, whether it is means any group which show plus I effect, जैसे अल्काइल ग्रुप्स हैं, दे इंक्रीज द इलेक्ट्रॉन डेंसिटी, तो देर एक्टिवेटिंग, या OH ग्रुप है या NH2 ग्रुप है जिसपे लोन पेयर हैं, एंड लोन पेयर on OH or NH2 group, they can be easily released on the benzene ring. So they increase the electron density on the benzene ring, and as a result of which benzene ring gets highly activated, and such groups, they are always ortho and para directors. What does this mean? It means कि these groups, these activating groups, they will direct the second substituent to occupy either ortho or para position. And in some cases such as OH, जैसे phenol है या aniline है जहाँ NH2 है, because all the three position, or that is ortho to ortho and meta para, all the three position gets simultaneously activated. So in that case we get ट्राई सब्स्टिट्यूशन. तो उस केस में हमारे पास जो है वो ट्राई सब्स्टिट्यूशन होती है, एंड दैट्स वी कैन से दैट इज, तो ऑल ऑफ द एक्टिवेटिंग ग्रुप्स दे आर ऑर्थो पैरा डायरेक्टिव, वेयर एज हेलोजन इट इज एक्सेप्शन, वी विल डिस्कस इन आफ्टर सम टाइम, वेयर एज जैसे इसमें फॉर एग्जांपल दिया है मिथाइल ग्रुप ऑफ टोल्यूइन इज ऑर्थो पैरा डायरेक्टर, तो टोल्यूइन रिएक्ट्स मोर रेडिली देन द बेंजीन. व्हाई? बिकॉज इन टोल्यूइन मिथाइल ग्रुप इज द एक्टिवेटिंग ग्रुप. सो we can compare the reactivity of compounds on the basis of groups which are present on the benzene ring. If there is activating group on the already present on the benzene ring, then that compound will be more reactive than benzene towards electrophilic substitution reaction. जैसे toluene जो है, it is more reactive than benzene. You can see given the example. And then ortho meta para. So ortho position is 63%, para position 34%, and there is slight formation of 3% of the meta. So mainly ortho para. Whereas deactivating groups, जितने भी deactivating groups हैं, चाहे वो नाइट्रो ग्रुप हैं, चाहे वो कार्बोनिल ग्रुप्स हैं, चाहे वो हेलाइड छोड़ दो, कार्बोक्सिल ग्रुप है, नाइट्राइल्स हैं, सल्फोनेट्स हैं, they are deactivated. They deactivate the benzene ring towards the electrophilic substitution reaction. And all these deactivating groups, with the exception of halogens, all deactivating groups, they are meta directors. They direct the second substituent to occupy meta position. And if we compare the reactivity, then benzene ring having deactivating groups means compounds having deactivating groups on the benzene ring, they will be less reactive than the benzene towards the इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन। कि जैसे मैंने अभी बताया कि जो टॉल्विन है इट इज मोर रिएक्टिव देन बेंजीन। क्यों? क्योंकि टॉल्विन के ऊपर एक मिथाइल ग्रुप है और मिथाइल ग्रुप जो है वो आपके पास इलेक्ट्रॉन लीजिंग ग्रुप है, वो एक्टिवेटिंग ग्रुप है, तो बेंजीन को रिंग को एक्टिवेट करता है, इसलिए टॉल्विन में इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन जो है बेंजीन के कंपैरिजन में क्या होती है, वो जल्दी हो जाती है। बट इन केस ऑफ अगर हम नाइट्रोबेंजीन लें तो नाइट्रोबेंजीन में नाइट्रो ग्रुप इज डीएक्टिवेटिंग ग्रुप, सो इट डिक्रीजेस द इलेक्ट्रॉन डेंसिटी ऑन द बेंजीन रिंग एंड एज ए रिजल्ट ऑफ विच अटैक ऑफ इलेक्ट्रोफाइल जो है इट गेट्स स्लो डाउन। तो इलेक्ट्रोफाइल जो है डजंट अटैक इजीली ऑन द बेंजीन रिंग एंड इन दैट केस वी कैन से कि नाइट्रोबेंजीन इज लेस रिएक्टिव देन बेंजीन टुवर्ड्स इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन। सो यू कैन सी दैट इन तो मेट्रो जो है इट इज यहाँ पे मेटा के जो अमाउंट है वो मैक्सिमम है, ऑर्थो पैरा जो है वो 6 and 3% ओनली, तो 91% जो है इट इज मेटा सब्स्टिट्यूटेड नाइट्रोबेंजीन। सो दिस इज इफेक्ट एंड द थर्ड केस इज हमारे पास ऑर्थो पैरा डायरेक्टेड डीएक्टिवेटिंग ग्रुप। तो फर्स्ट जो क्लास थी एक्टिवेटिंग हमारे ग्रुप्स की डायरेक्टिंग की, तो वो थी एक्टिवेटिंग ग्रुप, इलेक्ट्रॉन लीजिंग ग्रुप विच आर ऑर्थो पैरा डायरेक्टिव एंड एक्टिवेटिंग। दूसरी हमने पढ़ी टाइप वो थी इलेक्ट्रॉन विड्रॉइंग ग्रुप्स एंड मेटा डायरेक्टरी, एंड द थर्ड वन दिस इज एक्सेप्शन deactivating group halogens, they are deactivating, weakly deactivating, but ortho and para directory. So why benzene halogens, fluorine, chlorine, bromine, iodine, though they are deactivating but still they are ortho para directory? Why? Now benzene, because halogens जो है they are highly electronegative, so they withdraw electron density from the benzene ring toward themselves, so as a result of which they decrease the electron density on the benzene ring, and as a result of which attack of electrophile on the benzene ring gets slowed down. So benzene reactivity of benzene halobenzenes becomes less than the benzene. But why the second substituent, चाहे हम halogenation करें, नाइट्रेशन करें या Friedel Crafts alkylation करें या acylation करें, why this substitution takes place or ortho para position? Now this is because we can see, अगर यहाँ स्लाइड मैंने बनाई होगी तो ये दोबारा again I have classified activating group, electron leasing group, increase the electron density cloud to favor the electrophilic attack, stabilize the carbocation जैसे phenol, ortho attack, meta attack, para attack. So we can see, so now we can explain कि when electrophile attacks on ortho position, there is formation of these four regenetic structure of the carbocation. When electrophile attacks on the meta position, again there is formation of four regenetic structure of the carbocation, and this structure which I have marked with the arrow, it is the most stable regenetic structure. And in case of meta attack there are only three structure. So in case of if electron leasing group is present on the benzene ring, then the carbocation which is formed by the attack of electrophile on ortho and para position is more stable than attack on the meta position. So as a result of electrophile mainly goes to either ortho position or para position, इसलिए हम कहते हैं कि electron leasing group जो है they are ortho para directory. Then deactivating effect. So we can see that in case of deactive effect, there is one structure, this structure which is shown by the yellow arrow. In ortho and para it is most unstable. So in ortho para attack, when there is deactivating group present on the benzene ring, the arenium ion or carbocation is mainly resonance hybrid of only two structure. But in case of meta attack, there are three resonating structures. So we know that more is the number of resonators, the more is the stability. So in case of deactivating group meta attack, a carbocation formed by the attack on the meta position is more stable, इसलिए all जो है deactivating group, they direct the second substituent to occupy the meta position. Now halogen as a substituent on the aromatic ring, इसमें माइनस आई इफेक्ट भी है, बट एट द सेम टाइम देयर इज, मैंने जैसे पहले बताया, मेसोमेरिक इफेक्ट है, एंड माइनस आई इफेक्ट के कारण देयर इज डीएक्टिवेटिंग इफेक्ट, बस प्लस आई इफेक्ट के कारण जो देयर इज electron density is more at ortho and para position if we look into the regenerative structure of benzene. And because of mesomeric effect, because electron density is more on ortho and para position, so electrophile जो ortho para पे जाता है, but because electron density overall on the benzene is less, इसलिए benzene halobenzene जो है या chlorobenzene जो है, it is less reactive than benzene towards electrophilic substitution reaction, but it is ortho and para directed. तो halogen जो है, though they are deactivating, but still they are ortho and para directed. So there are three classes of directing groups. One is activating group. Activating means electron leasing group, they are activating group, they direct the second substituent to occupy the ortho and para position. Then second class is deactivating group. Deactivating group, they deactivate, they decrease the reactivity of ring towards the electrophilic substitution reaction, and they direct the second substituent to occupy the meta position. And halogen is third class, which is deactivating but ortho and para directed. So we can see the energy profile of slow step in the electrophilic substitution reaction. This is the general reaction in the absence of benzene, only benzene. But when there is deactivating group is present on the benzene, already present on the benzene, then this energy gap between transition state and the reactant increases. It means activation energy increases, and as a result of rate of the reaction जो है वो becomes slow, rate less. But in case of activating group, this energy gap between the reactants and the transition state decreases, and reaction जो है it becomes fast. So activating group, they increase the electron, that is rate of the reaction toward the electrophilic substitution reaction. So this is a summary of the classification of the substituents. We can go through it quickly, and thank you very much.